Welcome to the 46th video in our series about Unix tools. In this video, I will show you more about the GDB debugger. But first, let's review some of what we learned in video 45. To disable the colorization for the current session, you type set style enabled off. However, GDB will forget that when you quit. To make sure that command is automatically run every time you use GDB, you can put that command in a special file called .gdb-init in your home directory. Another problem we had was listing the breakpoints. We didn't know how, and then we solved it. We could say info break. We could also delete them. After info break, it shows the number of each breakpoint, and you can do delete and the number, and it will delete that breakpoint for you. Great. So let's get started on this video. If I get the focus correct. There we go. If we take a look at our files, you see I have one that's suspicious called buggy.c. Let's compile it, and we'll turn off the optimization. We will allow debugging. We're going to compile it only to buggy.o, and then we're going to link again. I said we were going to disable optimization. Whoops. 0. Okay, then let's link it with debugging. Okay. If we check, there's the file, and it says it's with debug info, and it's not stripped. So that means the debugging information is available. Let's take a look at what this program should do. If you look at this program, I've defined a function called isEven. And the way I do it, I send an integer pointer, and I say if the value modulo 2 equals 0, then I return 1. Otherwise, I return 0. Okay, so looks pretty good. In main, I've declared some variables. I put 99 million into X, and I ask for isEven, and I print 99 million is even when that's true, and 99 million is odd when it's false. So you would think this program is going to say 99 million is even. And you say, okay, let's run it. And it says 99 million is odd. And at this point, you might be mathematically challenged. I realize Thailand's educational system has degraded some, but you can go into Python and you can say 99 and 6 zeros mod 2. This will return true if it's even and false if it's odd. It returns true, so Python knows that 99 million is even. So, wow, we've got some kind of bug in our C program. And we've got a debugger, and we've compiled for debugging. So let's go into Buggy. And let's list. And the problem is probably in the isEven function. So we'll break on isEven. And now we're going to run. And it says I'm breaking right here. And if I do a list, it'll show lines nearby. I'm on line 5. So we're getting ready to run this code. And we're going to say, well, what is the value of star X? What? It's supposed to be 99 million. And I've got this silly number. Well, maybe we just print X. X is even worse. It gives us this. and we say, something is fishy about X. Right? Something is fishy about X. So let's list. And what we should do is we want to break on line 13. Well, line 13 is not a function. But we can just break on 13. And it says buggy.c line 13. And if I do an info break, you'll see I have 2 breakpoints. So I'm going to run the program starting from the beginning again with R. And it says, are you sure? And you say yes. Okay, now I break on line 13 and I say, hey, what is the value of Y right now? And it says, it's this stuff. So let's print star Y. And it's that. Aha. Uh-huh. And we saw that number before. I know we did. Where did we see it? We saw it right here. And there's the same number again. So we have identified the problem is something about Y on line 13. Right? When we send in the value of Y, if we list main, you can see that Y is an integer pointer, and we never set Y. We never set it. We set X, but we didn't set Y. So with just a little bit of this debugger information, we have found the bug in our program. This should be X, not Y. So let's go out, exit, say, yeah, I'm ready to exit. Let's go into Buggy. Change the Y to an X, because X is the one we set. We didn't use Y anywhere. Save. And then, because we haven't made any kind of script, we have to compile the C source code to the object code, and then we have to relink the object file into the executable, and then we run Buggy, and it says segmentation fault. I mean, this is just not my day. A segmentation fault is usually the result of some bad pointer, and we just fixed the pointer. How could this not be working? And so we go back into GDB, into Buggy, and we say, all right, I'm going to break on line 13 again, because that's where I learned everything. And then I'm going to run, and I'm stopping. It stopped on line 12. It didn't really do anything. Let's step, and it says, I've terminated with a SIG-SEG-V segmentation fault. Wow. That's exactly what happened before. And you might wonder, okay, let's break on 12. And we do an info break, and we see I've got a breakpoint on 12 and a breakpoint on 13. I'm going to run again. It says I'm on line 12. I'm going to print star X. It says it's junk. I'm going to step. I'm going to print star X. It says it's junk. Even star X is junk. Star Y has been optimized out because it wasn't used, even though we set our optimization level to 0. GCC in 2024 is very aggressive, and it just optimizes even when you tell it, please don't optimize. It says, yes, sir, and then it optimizes anyway. But there is an X, and the X has a junk value. It's got this value in it. And you have to ask yourself, why? Why is that a junk value? And, 99 million, that's definitely an integer. And when we looked at our program, it said, yes, I'm an integer pointer. What's the problem with integer? I don't get it. So you might say, tell me some info about X. And it's, I don't have any info. Info about star X. I don't know what you're talking about. And then you say help info. It says info address, registers, arguments, bookmarks, breakpoint, info on almost everything. And what we need to know is info about the type of some variable. And we're asking ourselves, how can I get that? Well, there was a locals. And it says there's an X, and there it is, and it tells you, you know, this looks very much like the OBJ dump, but that's all we've got. We've got info locals, we get X and Y, but we don't get any types, so let's info types, and it shows, oh my gosh, look at all this stuff. So let's quit that. Info types int, and it says int. I've got unsigned int, and it tells you unsigned. Wait a minute. Unsigned int is 32 bits. Okay, and type def int is int 32. So we see that integer is a 32-bit number. Okay, what does that really mean? We learned BC before. We'll do 2 to the 32, and we see, how many? 1, 2, 3, 4, 5. It should be big enough. It looks big enough. It looks like it goes to 4 billion. Come back for the next video when I explain what the problem really is. For now, think of this as one of those old-time serials, and the lady has been tied to the railroad tracks, and the train is coming, and we're waiting for our hero who will be here in the next episode. Thank you for listening.